All right, welcome back, YouTube. Today we're going to talk about different types of composting that you can do, and the times where you would do one versus another, the pros and cons of each type. So the first type of composting we're going to talk about is going to be the simplest one. It's going to be chop and drop, tossing organic material down onto the soil. This can be even as simple as putting wood chips down on the ground, using not kitchen scraps, but garden scraps on your soil, on the top of your soil. Or it can be even something more elaborate like an in-situ worm farm. This type of composting is going to be used when you really don't want to necessarily micromanage all your compost. You have excess garden scraps that you want to get rid of, and you just want to be quick and dirty about it, and you want to feed the soil life. As well, where you don't have an excess generation of kitchen scraps to deal with. So chop and drop compost is as simple as it sounds. It's literally this simple. It's just taking this rhubarb here. Maybe let's pick one. Say you want to eat this rhubarb. You can't eat the leaves because they're poisonous. So you just take the rhubarb, you're going to eat this. It's actually really good. And then you're going to take this leaf, or any organic material that you have, kitchen scraps, garden scraps, and you're just going to pick one of your favorite trees or plants. You're just going to cover the soil. You're just going to chop, and you're going to drop. That's all you're doing. Now you can do that specifically, intentionally, by planting specific plants that are going to bioaccumulate a ton of leaf matter. And ideally you want to do this actually with plants that have very deep tap roots. These are called deep tap-rooted nutrient accumulators. My favorite one, and everyone who watches this channel is going to know what it is, it's comfrey. Let's go look at some comfrey. Here we have one of my favorite swales, and the grass is a little bit long and it constantly wants to creep into the swale. So instead of micromanaging and putting a plastic border and then having to deal with when I have to remove it because it's cracking or breaking or whatever, I did a line of comfrey. These things have ridiculous tap roots and very extensive root systems. They drill deep, deep, deep down, way lower than most plants. These things have been known to dig 50-foot deep tap roots. And I'm not exaggerating, 50-foot deep tap roots. So what this plant does is it's kind of like a hosta. It looks like a hosta. It's a perennial. It drills that root way down low, far down low, and then it takes the nutrients from that soil that nothing else is competing. None of this stuff is going to have a root system that's that far down. It's going to drill those nutrients, send it up the root and into these leaves. This is one of the most nutrient-rich bioaccumulating plants on the planet Earth. All those nutrients get put into the leaves, and then I let this grow. I eventually come by with a rice knife, and I'm going to chop it, and I'm going to feed it to my garlic. And I'm going to do this over and over again. Feed it to the garlic, feed it to a fruit tree. Except I'm going to do it en masse. When the plant has larger leaves, this thing's going to get very large. It's also very easy to propagate. I bought 2 comfrey plants maybe 3 or 4 years ago, probably closer to 4 years ago. And every fall, what I do is I dig some up, I take tiny little cuttings of my comfrey plants and plug those into the ground. I just put them horizontally. If you know the root orientation, you can do it that way. I'll do a video down the road of propagating comfrey. Super easy, can't mess it up. You just put root fragments in all along. And then this acts underground. If you could have an x-ray and see underground, this acts as a wall, a rhizome barrier, and that will prevent some of these grasses from creeping in. You can see it's actually been 3 years for this swale, and although there are some grasses trying to creep in, for the most part the comfrey is strangling it out. You can see areas where I don't have it quite as thick, some of the grasses are getting in. So my response to this is to dig those up and put a comfrey plant there. I probably had comfrey plants here that didn't come up, so I'm going to put a couple more there, and so on and so forth, and make a big wall. Now underground, this plant here will actually make a very large plant. Like when these leaves are done, this plant will be this big. That's how big this gets. So this wall will close in, and underground, because plants kind of match above ground, below ground growth, underground the root system is just as big as that. So I use these as chop and drop plants that they also have a medicinal function as well. But you don't eat them. You can use the leaves as chop and drop, and you can also use them as comb-free tea fertilizer, which I'll actually talk about maybe at the end of this video as an add-on segment. But this is how you do chop and drop, and you can use any plant to chop and drop to another plant. If there's a weed you don't like, chop it, drop it to the plant that you like. So say this was a weed and I didn't want it, I would just chop it and I would drop it and feed it to my hazelnut or my hascap. And I would do that in a big way, not just a leaf like that. I would cut big swaths of this and cover the soil. That cycles the nutrients back in. It's essentially composting. And you can combine that with an end of season garden cleanup, where you're taking all your other garden scraps, chopping them, dropping them, using them as mulch, returning that nutrient back into the soil. Very important. What we take out of the soil, we must put back into the soil. Another form of in situ composting is essentially just putting down any organic matter. Wood chips counts, mulching, that all counts. So this is an area where I noticed the wood chips were getting a little thin, so I came with a box of wood chips and spread it all out. This counts as composting. Okay, the last form that I want to talk about is in situ worm composting, in situ vermicomposting. This here is some plants that I bought from my pond. I actually went out and splurged and got named cultivar sea buckthorn. So these are very interesting. I'll talk about them maybe later. But what I can do is after I plant these, I can take these buckets, and they'll already have holes in the bottom of them. I can add a couple holes so that worms can get in and out. Maybe drill some holes all up the side. And then I can bury this bucket down into the soil, maybe around fruit tree, in a garden next to where I grow tomatoes. And then I can fill this bucket, the bottom maybe with a little bit of gravel to help with drainage, and make sure that the holes on the bottom allow the worm tea to get out, all the worm manure to leak out and come out of that bucket. And then I can fill that bucket with kitchen scraps and replace the top with mulch. The worms will actually come, this will be buried in the ground right inside my garden. And the worms will come in and out, they'll eat the kitchen scraps in the bucket, they'll manure inside the bucket and come back out. And they will actually turn a bucket full of that compost very, very quickly, like within a couple days, easily. If you want to do something like this, you want to get composting worms ideally. So you don't really want big fat earthworms. You want small composting worms called red wigglers. Get a couple of those from a local bait store, put them in the bucket, give them some lettuce and veggies and whatever to eat, maybe some newspaper, sawdust, wood chips on top, and you're good. Then, when you're doing your kitchen scraps, come back in, pull the mulch out, put the new kitchen scraps inside the bucket, and recover it. And you can have little plugs of these in situ worm farms all throughout your garden. This way, they'll turn over your kitchen scraps. It'll be covered from animals. Some animals might get into it, you know, like a raccoon. It's not going to keep a raccoon out. But for the most part, your kitchen scraps should get eaten by the worms, turned into compost, vermicompost. The best worm castings are the best compost soil amendment outside of maybe biochar that you can put into your garden. And then it's in situ, it's easy to do, and that is a way that you can handle your garden kitchen scraps. Now let's talk about the Berkeley method of composting. I've done a previous video specifically on this one. It was one of the first videos I did. It can be a little convoluted and complex, so I did a step-by-step guide on how to do it. I'm not going to talk about all that now because there's that other video and I'll link to it right here. But for this method, you need to get a critical mass pile. It absolutely has to be at least 3 feet by 3 feet by 3 feet. Or in terms of a pile, a cone, that's roughly 5 feet wide at the base and in a cone. It has to get that big because this method is going to be primarily driven by bacteria, and they need perfect ecological conditions to multiply and thrive. they have to be in the range of 200 or 120 Fahrenheit to 180 Fahrenheit in order to multiply. That's where the really quick multiplication happens for bacteria. Any hotter than 180 Fahrenheit and they'll start dying. Any colder than about 120 Fahrenheit and they kind of just don't do anything. This method also needs a proper carbon-nitrogen balance. All methods generally will require this, but this one really needs it. So you need roughly 4 parts to 1 browns to greens by volume. And that browns are anything that's very carbon heavy. So sawdust, wood chips, newspaper, cardboard, anything that is like very, very carbon heavy. It doesn't refer to the color of the thing. Green are high nitrogen loads. So this can be kitchen waste, garden scraps like leafy garden scraps. It can be urine. It can be animal feces, but there's cautions in doing different animal feces as well. It's probably better to just keep it out of the compost. It could be fish waste. So many different things that are high nitrogen. Typically like bones and blood and skin and all this sort of stuff. That will go in here, but you also have to be careful with meats and just dead living beings, because that's really going to attract stuff like raccoons and rats and a bunch of vermin that you maybe don't want to have in your neighborhood. And your neighbors probably don't want you having it either. So it's probably better that you stick to just kitchen scraps, garden waste, and another great nitrogen source is coffee grinds. Coffee shops give these out for free. They have to pay to get rid of them. The strengths of the Berkeley method is that it can handle tremendous volumes, huge volumes of waste. And it does it quickly. This is probably the fastest turnover cycle because bacteria just chew through this stuff. Another pro with this method is that it handles food scraps. You're typically going to do it in a locked container with airflow. It's really important to get airflow, which I'll talk about in a second. But typically you're going to have it kind of locked away from, raccoons and that sort of thing from getting into it. So comparing that to, say, in-situ composting, a tomato, if you put a tomato out inside your garden just on the ground, something's going to come get it. If you put it in a compost bin, then it is actually going to get composted and turned into soil, and the nutrients going to get cycled before something goes and takes it away out of your system. Now, the only real con with the Berkeley method is that it's a ton of work. You have to constantly be taking it out, rebuilding your pile, turning it, and if you don't, you're going to get potentially a slimy mess. It's going to turn anaerobic. It's going to start stinking like really, really bad. And you're going to start generating methane, which is like 30 times worse than CO2. And it's even 100 times worse in the first decade of its life in terms of being a greenhouse gas. So if you really want to be eco-positive and you want to compost, and you're going to do it in a Berkeley method in a compost bin, please, please, please keep your eye on it. Keep it going. Get oxygen into that pile, because if there's no oxygen to make CO2, then the soil microbiology that's in the compost will turn anaerobic. Anaerobes will start multiplying because they've got perfect conditions with no oxygen. And they're actually going to decompose stuff into methane, which is CH4. And methane's really bad. So we really need to make sure that we don't produce methane when we compost. That's what giant piles of waste food, that's why they're one of the worst greenhouse gas emitters, is because they make so much methane. And it's why the cows are, demonized and made evil outside of, animal cruelty reasons, but in terms of greenhouse gases, because they also make a bunch of methane when they're fed a bunch of corn. So methane's really bad. We need to really make CO2. So please, if you're going to do composting method, check out my compost video, follow those steps, follow the steps in this guide, and get that oxygen into the pile constantly. That will also speed the process up, but it'll also keep you eco-friendly. Okay, so here's the compost pile. You can see I like to run it fairly brown. We're going to give this a turn. We're going to check it for moisture. We're going to get oxygen into that pile, and we're going to make sure that we are adjusting and keeping this thing running optimally. Okay, so now we've given it a turn. We've added a little leaves on top for shelter, for the soil microbiology, just another insulating layer. If it was really wet, I would add more leaves as I layered it and rebuilt it. And if it was a little dry, I would take water from this pond and I would put it in. The moisture was pretty good. And for the most part, it didn't smell. It had been a little while since I had got to this pile because I've been so busy. And you're never going to get to it as often as you can, as you think you want to. But the ideal amount of times you do the turn is every 2 days, believe it or not. 2 or 3 days, that's how fast. The more you turn it, the more oxygen you get into there, the faster it'll go bacterial driven. So you don't have to do it every 2-3 days, but that's the ideal. Okay, so what if you don't want to do it every 2 or 3 days turning it? That's not the worst thing in the world. But what it means is you're actually going to do cold composting. So what's going to break down, because the pile's going to cool down because you're not infusing it with oxygen all the time, the pile's going to cool down a little bit and slow down. And what that means is the temperature's going to come down. And when the temperature comes down, earthworms and pill bugs and flies will move in. Now, some of the best composting organisms you can get are called black soldier flies, and we'll talk about that in another section of this video. However, if you do cold composting, I just, with the whole methane thing in mind, if you do cold composting, really try to run it a little extra brown. Put a little extra cardboard, newspaper, leaves in there. The worms will really like that. And then you're also going to keep the pile kind of, the carbon acts like a sponge. So you're going to keep it a little cooler. The smells will get absorbed by the carbon, and it'll give more area molecularly to bind nutrient to. And then, like I said, it'll just protect all the soil life as well. So if you're going to do cold composting is essentially the same thing as the Berkeley method, but higher carbon. It's going to take longer, but it's less work. Okay, so whether I do hot composting or cold composting, what I do with it afterwards is I put it down near one of my garden beds, uphill of a swale ideally, and then I cover it with wood chips. I try to inoculate some wine cap mushroom into it, and I just let it kind of sit here for a couple months. What this does is it lets it build up the mycelium component in this. And I do this because I don't do veggie gardens as much as I do food forest expansions with trees. So I want to take that compost soil that's bacterial heavy, and I want to turn it into fungal heavy soils. So I mix it with some wood chips, and I start building the fungal component of this soil. And look at how nice this ends up. This just turns out to be such nice soil. And you can notice I also do biochar. So I have charcoal that I put into the compost back when it's doing the hot composting process, and it ends up coming out in this part and just absorbing all the nutrients. This is such incredible soil for your garden, and especially for trees. Getting that fungal component growing inside this compost is very, very good. And you can see that I do lots of composting, because even here behind me, you know, there's traces of tons and tons of biochar just littered all throughout the soil. And this whole entire area is probably some of my best soil, even though I don't have any trees planted in it, just because this is where I do my composting, where I let my composting finish. I've talked about this in previous videos, but the reason I let my composting finish here is because the slope kind of goes like this, and when it rains, all that rainwater hits my compost and it'll pick up soil microbiology. So it'll pick up all the bacteria, even little spores of fungus, kind of wash it down into my swale, and then it'll spread out and then sink into the fruit trees, and all the fruit trees will get that nutrient-rich compost tea automatically, no effort from myself, just free nutrients, healthy nutrients, aerobic nutrients for all my fruit trees. See, so I'm a really big fan of getting as many of those automatic passive systems into your overall design as possible, because that just reduces work. Every single time it rains on that swale, it becomes not just an irrigation event, it becomes a fertigation event. It becomes fertilizer for my fruit trees, all passively, and I don't have to do anything about it. Now, if you don't want to buy big compost bins, then what you can also do is just go to your local industrial area of town and look for some skids, some pallets. And then you can build a multi-bay composting system. This here I used to use. I don't anymore, and I should take it down, I know. But basically what I would do is I would put leaf bags in here as I collected them. You can tell how small I made that because I didn't know how many leaf bags you need. Like this should be the size of all of this. But I put my wood chips or leaf bags in there, and then I would do my first set of composting in here, and I would basically add these drawers on. So I would put the load. So I would put the compost in there, build it up, and oxygen can really get at this from all sides. I mean, you can make it really big. This is roughly that 3 foot by 3 foot by 3 foot size. Obviously, you know, you could ideally do a full-size pallet there. And the idea was that this way, every single time I turn my pile, I could have 2 piles going at any given time, and I could take this off, take that off, just push this pile and put it over there, and then reseal it back up and start a new pile. And then every couple days, move it down to the next bin, and then leave this one open, and a couple days later, move this one into here. That way you're turning it really quick, you're cycling it through really fast, and it's very, very easy to do. So why don't I use this? This is actually ideal, and it's better than what I do right now. So why don't I use it right now? This is actually really far away from the house, and I have very long winters. So we have winter more than we don't have winter. So when it's really cold outside, I don't really want to walk all the way from the house, way up there, all the way down here to these compost bins. Because of that, I did my composting more close to my house. Video, your zones in permaculture. I put my compost bin more in my zone 0, zone 1. Now I was going to do that up here, but my better half told me there's no way in hell you're putting something that ugly up near our house. So instead I have this here, which is compost bins, spent O-pipe. I'll get rid of that. Leaf bags. It's not a whole lot nicer, but she likes this better. But ideally, I would be doing that here. Now, what is good about these is that you can go like this with them. You can lock them. So if you have rodents nearby and they're going to get into your compost, having an open bin like I have way down there is probably not the ideal setup, because they'll rummage through it, they'll throw it everywhere, they'll eat all the stuff you're trying to compost, and you're going to attract them. So they're going to be there tomorrow and the day after and the day after. So maybe where I have that first bin set up where I was putting the leaves, you could have a couple of these, you could rotate them through those as you rebuild one into the other. They could spend their first 2 cycles in here, and hopefully by the time they hit their 3rd cycle, they come out of here not looking like anything that something wants to eat. They'll be mostly composted, and then they'll just finish in those last couple. But if you do a quick turn, you're turning every 2 days, you're adjusting for how much carbon's in there. If it's a little too wet, you add a little bit more carbon. If it's a little too dry, you add a little bit more nitrogen. You know, just go take some plant cuttings and stick it in there. Take some grass clippings, stick it in there. Or, you know, do your natural business and stick that in there. And, you know, number 1. And That'll get more nitrogen in the pile, it'll fire it back up. It's already a little too brown, so you don't have to worry about smells, because the carbons will absorb all the smells, and the oxygen, you know, it won't even be that material anymore after a very short time. So that's another option. Use a couple of these bins in the first couple bays. I really would like to do that, but I will never be able to do that because my wife will not let me have big composting bins up here. Maybe I could build a shed and kind of hide it. Maybe she'd like that, but then I'd have to get a permit. Unless I built it 9 by 9, but then that's not big enough. Do you see the problems? Okay, just a quick one on stuff that I know I'll get asked, because there's a bunch of different kind of container-based composting setups. One that I hate, and I think one that everybody that does hates very quickly after they do it, is tumbler style composting. I think it is terrible. This here's the best example I can get of it. This is where I do my biochar in. You can tell I'm getting ready to run another batch. A container style composting is basically this on legs on both sides with a little handle out here, and this would be a lid, and there'd be air holes drilled in and yada yada yada. And the idea is that you fill it with your compost and then you can turn it, so it makes turning it easier. Why does it suck? Why do I hate it so bad? First reason is that this is actually bigger than most of them are that you would buy in the store, and this is not critical mass size. This is too small. So imagine also, the more that this fills up, the harder it is to turn, and then the less that the tumbling actually does anything. So in order for you to get a good tumbler method, you actually have to build this thing massive, because everything is going to settle out on the bottom. So picture this thing full. Any higher than about 2/3, and this thing's not going to tumble and actually do anything. It's just going to turn, and there's a bunch of stuff in there. It's not going to get rotated through. Any lower than, like if you get down to two-thirds of the height, you've only got 1 foot depth. So you got 1 foot depth, you've got less than 2 feet across. It's not even, you know, it's a circle shape, and it's just not big enough. It's not even close to big enough. What that means is it's not going to do anything. It's not going to get up to that critical mass size to really go. And it's a pain in the butt to empty. And it's really hard to get oxygen into the pile. You could drill this thing full of air holes, and all that's going to do is cause all your compost leachate to drop out of the bucket and go all over your driveway or whatever you have underneath it. Furthermore, when I have composting up in the bins, I have ground contact with that composting. So worms can actually come in and out of cool spots. When this thing's elevated off the ground, it's very hard for any kind of life to come in and out of there as it needs to do it. So it's very hard to actually get the things to go. So maybe someone else has a different experience with those things than I do. They're a waste of time. Don't do them. You need, if you're going to do proper composting and you're going to do it in a bin, you need it big. Those bins that I have up there, they're too small. I wish I could get a bin that's twice as big as those. Big size matters. It has to get to critical mass. The more critical mass, the bigger it gets, the more that activity center zone where that bacteria loves those conditions, the bigger that zone is. And it scales exponentially with the size. So when you're really small, 5% of your pile might be active composting. The bigger you get, you can drive that up like a huge pile. Picture like a 1,000 yard pile of compost. That thing is probably 95% an active zone in the center of it that's good enough for the bacteria. It has to get turned more because it'll get anaerobic very quick. But a big pile has a big active zone and it goes fast. Smaller you are, especially these tumblers, you're going to get anaerobic fast. You're not going to get because you're not getting the oxygen in there. It's hard to get the life in there. It's hard to pull it in and out. So you're making one tiny piece easier, the tumbling, the turning, but you're making everything else harder, and it's going to be way worse. Avoid those tumbling compost bins. Just run an open pile. Stick a tarp all over top of it so that you're not leaching out the nutrient before it's ready and finished. And yeah, just do it. A big open pile is better than nothing. And for the last types, we're going to do them both together, and that's going to be indoor composting. So if you have an apartment building, if you just have a small garage that you want to do your composting in, if you don't have much land but you still want to compost and cycle your nutrient and be eco-friendly, then these are the types for you. It's going to be Bokashi, which is a fermented bacteria, which I'm going to kind of combine with like a digester, an anaerobic digester, as well as vermicomposting. These are things that you can kind of do in a very small space, and they're basically sealed container composting. Now these are going to be very quick because I don't have an actual setup to show you, because I have space, so I do the other things. They're more efficient for me. But if you're going to do vermicomposting, you would take a tote. I'll just use this as an example, but just like a typical moving tote. And what you want to do is put a drain hole in the bottom, but in a way that you can seal it. Ideally some kind of tap that you can open and close, like a little spigot. And you're going to close it up. And you're basically going to layer in food waste and cardboard. And then you're going to run it half and half. So you're going to layer in food waste and cardboard. You can put a dividing sheet in the beginning. It'll be a square, it won't be like this. And put all your worms in the one side. Again, this is going to be red wiggler worms ideally. Layer it up, seal it up, lots of cardboard, and just layers of cardboard, newspaper, and kitchen scraps. Come back in a couple days and have a look at the worms. There are going to probably be millions and millions of worms. What you're going to do then is build the other side, take the divider out, let them find the new food. Come back another day later, and all the worms you'll find are in this new high area with all this awesome food. And then you're going to rebuild this side. And you're going to go back and forth like that. Now worms in this way can eat a ton of compost very, very quickly. Every time you check on the worms, you're going to double check to see how moist everything is. You're probably going to add a little bit of water. And when you want to get a really good fertilizer, you're going to stick this thing up. Maybe you can stick it up normally. Just put a small little 10-degree tilt on it, not much, like very, very slight. And that way all the juice will accumulate at the bottom. And then you just open up the spigot and you can get some of the worm casting, put it in a bucket, and then go fertilize your garden with it. That stuff's very good. You know, you can just douse it with, like, give it a good soak. All that will drip through. Just leave a can there to collect the drips over a couple hours or so. Come back, close it off, go fertilize your garden. So that's basically vermicomposting in a nutshell. Ideally it's done somewhere that you don't mind opening a spigot and you might spill some worm juice and all that. Ideally when you build the spigot, you can do it in a way that there'd be like a section pipe, maybe some gravel cover and block with like a tube with holes in it, and then put rocks around it. Something that will just keep all the sediment and food and dirt from getting in. It'll just be liquid that can get in there and out the spigot. Just some thoughts. That way you're not gunking your spigot up. That's vermicomposting in a nutshell. Now, Bokashi is kind of similar to vermicomposting, except it's done anaerobically and it's done with microbes. It's done with bacteria, I believe. And it's basically like a fermented compost. I don't really know how to do it. I could probably learn it pretty quick, but it's probably better to just send you to another, tell you to go look up an actual Bokashi video from someone who does it and is an expert. I hate when people aren't experts on something and they talk about it like they are. Because of that, I know that this is a hole in my knowledge because I don't do it. So I'm not going to go explaining to you guys and giving you guys false information. So go look up an expert in Bokashi, but my idea of it is it's kind of like worm composting, but with bacteria. Now, a methane digester is kind of similar, and the idea is that it's done anaerobically. It's again a ferment, and the off gases are, the methane is captured. So this is actually a decent way to do anaerobic composting, but in an eco-friendly way, because then you capture those off gases and you can use them and burn them for heating. So look at those if you're in like a small area: vermicomposting, Bokashi, and a methane digester. If you're like in an apartment building or If you're kind of off grid, but in a city, then something like a methane digester could be really good for you, because you could generate some heat out of the off gases of your composting, and then you could also compost in a way that's sealed. You're not going to kind of upset any neighbors, and it'll kind of be clean, neat, and tidy. You just have like this giant bucket, like large, like a rain tote sized, maybe even bigger, and then you just open the lid, throw your kitchen scraps in there, close it up, and let the anaerobes do their work and make methane, and then you're going to burn it for heat. So I hope you enjoyed this video. This is composting, alternative modes for composting, when you should use each one, and pros and cons of each. Okay, so just to summarize, chop and drop. The pros are that it's super easy. You can plant plants specifically to generate soil and compost, and just chop them and drop them down. You can make the forest floor fall by chopping nitrogen fixing trees and building the fungal component. You can build the bacterial component by chopping and dropping leafy plants down. And then you can also basically feed your weeds to it. Chop your weeds down, and eventually the roots will get starved of energy, and you're not disturbing the roots of the weeds themselves and making more weeds. So you're just going to starve them out of energy. So you want to do chop and drop when you have mostly garden waste, or you're just doing it as an ongoing maintenance of a system. Its weakness is that it's a really bad way to handle kitchen scraps, because throwing a bunch of kitchen scraps down on the ground is going to attract a whole bunch of rodents picking through your gardens. They're going to probably eat a couple tomatoes and then go, whoa, look at that, there's actual tomatoes on that bush over there, and they eat some of that. And then it's also kind of just not, like, a bit nasty, right? You have a whole bunch of kitchen scraps just decomposing on the ground. So, you know, you might cover them with wood chips and everything, but to me, it's best to leave chop and drop to your garden scraps, and just like it's an ongoing, I'm walking around my garden, I'm going to chop and drop some stuff, ideally with nitrogen fixers, so that every time you chop, you're flushing nitrogen under the ground to everything else around it. That's just like too good to be true in my mind. Berkeley method. Pros are that you can handle a ton of volume. Cons and pros are that it's a really good way to handle kitchen scraps. Cons are that it's a little higher work to do it properly, and the big con for me is that if you do it poorly, it's going to stink, and it's going to stink because it's making methane, and you're making a greenhouse gas, and here you are trying to close the loop and take care of your waste, and you're actually causing problems. So really practice that, make sure that you add a ton of carbon. And sometimes it can be hard to find all that carbon that you need. Wood chips, newspapers, cardboard. That's why I go grab 2,000 leaf bags in the fall, because I compost so much, because I have so many gardens. When I clean them up, I like to build really big compost piles. So tons of leaves is a really good thing to do. So in the fall, make sure you grab a ton of leaf bags if you're going to do Berkeley method hot composting. Cold composting, the pros are that it's kind of less hands-on than hot composting. The con is obvious, it just takes way longer. So you turn maybe a 30-day compost into maybe a year or year and a half long compost, because the macrobiology is the one that's going to drive it all. It's still some maintenance. You really should be checking to make sure it's not getting super aerobic or anaerobic. And you're kind of just adding little bits of compost all the time at it, so it's kind of never getting done. So you got to kind of section off portions of it so that you're not just like never getting out and getting your compost out, because there's always something in that pile that's like 2 weeks old or a month old and it's not finished. So you really have to be careful with that. Vermicomposting. To be honest, there's not a lot of cons with vermicomposting. The pros are that you know, you can do it in a sealed container, you can do it inside an apartment building. It's very easy to get done. I guess the cons would be that you have to build it. So you have to get the actual moving bin, you got to do the work, you should look at how to do it, you got to get the worms, but that's really not that hard. I don't do it because I can do open style composting. But if you don't have that room to do the Berkeley method, and like, you know, I just have to drive a ton of waste through this, then worm bins are great. Worm bins are a great option, and you should definitely look into it. The other pro with vermicomposting is that the worm the worm castings and the worm juice that you get is like, that's some of the best compost you can get. It's immediate, like it's bioavailable immediately. It's very, very high nutrient content. It is just, and it's very bacterial. So if you're doing lettuces and peppers and tomatoes and these kind of kitchen style garden foods, they want that bacteria heavy soil. So vermicomposting is just, it's perfect for that. Bokashi, my understanding of Bokashi is that it's actually a little finicky to get going. You have to really research how to do it, and it's kind of the same upstart cost as worm composting. But once you have it going, it's pretty, it's pretty easy to maintain. You're basically just throwing food in all the time. You might be balancing some stuff. Biggest con for me is I think it's a little more complex, but someone who's really good at Bokashi is probably saying, no, it's not complex, it's pretty easy. So if you're into an apartment, check it out. I don't quite know the pros and cons as well as I do with the other one, so just take that with a grain of salt. Methane digester. The biggest con, I think, for this one is that it's expensive. It's expensive to get going. You need a giant methane digester. I'm sure you could DIY yourself something small, but I think it's also going to be slow. I think it may not be able to handle a lot of volume. So you really want to do this large scale because you're trying to produce gas to use for heating, for cooking, whatever. So it needs to be a certain size to match whatever your gas consumption needs are, or else you're kind of going to plumb in all this gas fittings, but like maybe not really, like you'll use it for 2% of your gas needs. So it really needs to be able to meet your household needs, and it could be really expensive to get it started and get going. The pros are absolutely, once you get this thing started, then you can go around to restaurants and collect their restaurant scraps, and you can turn a ton of waste into fuel for your family. So you can also, if you make a little bit of methane, that food waste inside of a giant food pile somewhere is going to make methane. So you're really doing a double whammy on saving other methane emissions, but then you're also making fuel for yourself, and you're sequestering carbon and you're heating. So to me, it's like a no-brainer. It's if you really want to get into it and you have the money to put into it for the initial build, and you're going to be in that house for a while, and you're okay going around grabbing kitchen scraps and putting it in your methane digester, I mean, it's probably the #1 eco-warrior thing you can do of all the composting styles, because you're really intercepting that carbon emission, and you're turning it into something useful. So give that a look as well. Hopefully this set of guides really helped you out in deciding what kind of composting you want to do, what fits your life, and you can match the strengths of the composting to your eventual goals. Thanks for watching.